All right, here we have another quite uh, simple question, although it uh, wants to appear quite tricky, but it's quite very simple. You're given a matrix A and you're told to show that A plus lambda high is singular. Now, obviously, you understand that the high there represents an identity matrix, a 3 by 3 identity matrix. There are a couple of things to, first of all, be very aware of before you can be able to solve this. Number one, you need to understand what is I. So I is that matrix that you use as sometimes it looks like a mirror, and you have different you have high for a 2 by 2 matrix, and you can have it for a 3 by 3 matrix. This is what I looks like for a 3 by 3 matrix. It's called the identity matrix. This is what a 3 by 3 identity matrix looks like. Now, another thing you have to look at here is you're given a constant lambda, which is more like a scalar right there, a constant lambda, which was multiplied with the identity matrix. Then you are then given a plus that lambda high, and you are told that that a plus lambda high is supposed to be singular. So they said determine the value of the constant lambda so that a plus lambda high is singular. And the last thing you need to make sure you are very much aware of is the use of the word singular. So what does it mean for you to identify that a matrix is singular? Well, very simple. For a matrix to be singular, that means the matrix determinant is 0. So when you see the word a non-singular matrix, non-singular means the determinant is not 0. Singular means the determinant is 0. So the meaning of this question is that they are just saying determine the value of a constant lambda so that the determinant of this matrix is 0. Therefore, this is what they are asking you to resolve. A plus lambda high, the determinant of this being 0. So instead of, you can interpret is singular to just mean this. So they are saying, if they say a plus lambda high is singular, that means they're saying the determinant of a plus lambda high is 0. So this is what we have to resolve finally. So, but we have to take it one step at a time. So number one, the first thing we have to do is to first resolve a plus lambda high. That's the very first thing before we can go on to talk about it being singular. So to resolve a plus lambda high, we have to resolve, let's try and resolve it all at once, just for the sake of brevity. So we have a right here, minus 4, and 4, minus 1, 0, and 1, minus 7, minus 6, and 7. This is A. Plus, now we have lambda high. Lambda high. So what we will have is lambda high. This is I, as I showed earlier. So this is lambda high. So this is what we want to resolve first, before then talking about it being singular. So let's go on to resolve this quickly. Let's start with our lambda high. What we will have here is lambda. We would have lambda times, the way you do scalar multiplication is that you multiply the scalar with every element inside there. So what we have here is lambda times 1 will be lambda, lambda times 0 will be 0, lambda times 0 will be 0, lambda times 0 will be 0, lambda times 1 will be lambda, lambda times 0 will be 0, lambda times 0, 0, lambda times 0, 0, then lambda times 1, lambda. So this is what we have as lambda high. So we are adding A with this. So this is what I believe we should be aware of. Matrix addition. What we have to do next is matrix addition. Take note of the question. We are asked to determine the value of the constant lambda so that this is singular. So the next thing we have to do is to make the addition of these two matrices. And what you do when you're adding matrices is that you add every element. Row 1 column 1 here will be added to row 1 column 1 here. Row 1 column 2 here will be added to row 1 column 2 here. The same thing, you do the same thing for everyone. So here we have minus 4 plus lambda as the first one. So the first one will be minus 4 plus lambda. That's the first element. Then we have minus 4 plus 0. That will be minus 4. Then we have 4 plus 0. That will be 4. Then we have minus 1 plus 0. That will be minus 1. We have 0 plus lambda. That will be lambda. We have 1 plus 0. That will be 1. And then we have minus 7 plus 0. That will be minus 7. Minus 6 plus 0. That will be minus 6. Then 7 plus lambda. That will be 7 plus lambda. So this is our A plus lambda high. This is the matrix A plus lambda high. So now we are asked to determine the value for lambda such that this matrix, that's A plus lambda high, is singular. So what we are told to do there, obviously, as I said already, is that we're told to just evaluate that the determinant of this is 0. That's the meaning of is singular. So this is what they're basically asking us to do. So we need to go and find the determinant of this matrix. This is A plus lambda high right here. This is A plus lambda high. So we have to go on to solve the determinant of this matrix and then equate it to 0. From there, we'll be able to get our lambda. So let's try and do that very quickly. Finding the determinant of this matrix. So if you checked the previous video, you would understand that it's quite easy to solve the determinant of a 3 by 3 matrix. So what you have to do basically is to put a plus here. So there's a plus here, there's a minus here, there's a plus here. So you pick plus of this, minus with this, plus of this. So we have the first one plus minus 4 plus lambda. So then you would be deleting every element in row 1. You know, this value here lies in row 1 column 1. So you delete every element here, and pick whatever is the resultant. That will be what will lie in your determinant braces. So what will be lying here, since we have crossed, this is row 1, we cross it out. This is row column 1, you cross it out. You'll be left with lambda 1, then minus 6, then 7 plus lambda. So that's the first one there. So what we have here is minus 4. That's obviously going to be plus 4. So plus 4. Then we open our determinant braces also. So right here we are cancelling everything in row 1 because this minus 4 here, this minus 4 lies in row 1 column 1. So we cancel everything in row 1, we cancel everything in column 1, we'll be left with minus 1, we cancel everything here, we're left with minus 1, minus 7 plus lambda. So minus 1, minus 7 plus lambda. And then the last but not the least will be plus 4. So we have plus 4, then we open our determinant braces also. So here we are cancelling, this is plus 4, we are cancelling everything in row 1, we're cancelling everything in column 3. So we're left with minus 1 lambda, and then minus 7 minus 6. So obviously we have been able to bring out what we need to bring out for our 3 by 3 determinant. Now what we need to do next is to resolve this. Now you have to resolve carefully. So what we have here is, obviously this will be minus 4 plus lambda. So we have to find the determinant of this 2 by 2 matrix, which will be lambda times 7 plus lambda minus 6 times 1. So the way you do the determinant of a 2 by 2 matrix is to multiply the leading diagonal, that's this diagonal, and subtract the other diagonal from it. So this times this minus this times this. So this times this, that will be lambda times 7 plus lambda then minus 6 times 1, that will be minus 6 minus 6. I'm sure you can understand the use of the brackets there. So this is lambda times this minus 6 times 1, which is minus 6. So that's what we have there. The next one, we have plus 4 into brackets minus 1 times 7 plus 1 plus lambda. That will be minus 1 times 7 plus lambda, then minus 7. So minus 1 times 7 plus lambda, this is it right here, minus 7 times 1, which is minus 7. And then the last but not the least, we have plus 4 minus 1 times minus 6, that will be 6 minus 7 times lambda, that will be minus 7 lambda. So if you can understand the whole concept, so this is basically what we are doing right here. So we can go on to then resolve this equation. So you can see the resultant from here. What we have is what we have right here. So you can just follow through. What we just did is just to open up all the brackets and try to resolve that. So if you look at what we have here, we have our so if you can see what we have here, we have minus 7 plus 7. Though these obviously we cancel each other, and then we can easily open the rest. We have minus 28 lambda here plus, or let's rather open it once, minus 4 lambda square, then minus 24 plus 7 lambda square plus lambda cube, then plus 6 lambda, then 4, that will be so minus 4 lambda, then plus 24, then plus 28 lambda. So if you go through, you will see that it's the resultant of the whole equation. So we have lambda cube plus 3 lambda square plus 2 lambda as our resultant equation. Don't forget, this is also equals to 0 because we're trying to resolve a plus lambda I equals to 0. So looking at this equation right here, what we have to just do is to factorize lambda outside, and then we're left with lambda square plus 3 lambda plus 2 equals to 0. So from here we know that our lambda is equals to 0, and then we know that our lambda square plus 3 lambda plus 2 is also equals to 0. So we can easily use factorization to arrive at our final answer for this quadratic equation. So from here you would arrive at lambda being equals to -1 or -2. So obviously the three values for which a plus lambda I is singular, which obviously implies that the determinant of this is equals to 0, will be lambda equals to 0, lambda equals to -1, or lambda equals to -2. All right, so I hope you will be able to solve this. I would love you to drop your response, your results, what you are able to arrive at in the comment section. All right, guys, thank you for joining. Bye bye.